The fourth type of matrix is called diagonal matrix. For this, first of all, you have to consider a square matrix. So let us say capital A is equal to Aij is a square matrix of order M. Now this matrix is said to be diagonal matrix. There are two ways to write the definition or remember the definition. The first one is straightforward. A matrix is said to be a diagonal matrix if it's, first of all, it must be a square matrix, and all the diagonal elements are non-zero and the rest of them are zero. So A equal to Aij, Aij is not equal to 0 for all I equal to j. You can see that for all I equal to j, whenever I equal to j, it represents a diagonal element, right? And here I am writing it is equal to 0 for all I different from j. So for example, if I want to write diagonal matrix, right, I will consider this diagonal, which is normally called as principal diagonal. Also, you have to start from left top corner. So let us say 1, 2, 3. Now the rest of the entries must be 0. So this is called a diagonal matrix of order 3. So a square matrix is called a diagonal matrix if its diagonal elements are non-zero and the remaining entries are 0. So we can say that every diagonal matrix is a square matrix, but a square matrix may or may not be a diagonal matrix. The next type, which is again most important type, called identity matrix. Okay, let us first consider a scalar matrix. Now, to define this, first of all, we have to consider a diagonal matrix. So let A is equal to Aij is a diagonal matrix. And this is said to be a scalar matrix if all the diagonal elements are equal. So Aij is equal to k for all I equal to j, obviously k different from 0, and 0 for all I is not equal to j. So this matrix is called a scalar matrix. This is the definition of scalar matrix. For example, A is equal to 2, 2, 2. Now I am writing all the entries, all other entries as 0. So you can see that the difference between a diagonal matrix and a scalar matrix is here the diagonal elements need not be same, but as in scalar matrix the diagonal element must be same. So every scalar matrix is a diagonal matrix and every diagonal matrix is a square matrix. And the next and the sixth type is called identity matrix. So A equal to Aij is a scalar matrix now. Right? And consider Aij is equal to 1 for all I equal to j. And 0 for all I different from j. Then this matrix is called an identity matrix. this has a spatial notation, right, which can be written as I, and then the order of that matrix. So suppose I am writing identity matrix of order 3, then I will write 3 in the suffix. The diagonal elements are 1 1 1 0 0 0 0 0 0. Suppose I want to write down an identity matrix of order 2, then it is 1 1 0 0 and so on and so forth. So we have a chain of definition, right? A diagonal matrix, a scalar matrix, and identity matrix. So every identity matrix is a scalar matrix, every scalar matrix is a diagonal matrix,